So this lesson is about using the product rule and the quotient rule derivative shortcut formulas. There's a derivation of these rules on a separate video, so I'm going to skip that right now, and we're going to go straight into seeing what they are and then knowing how to use them. So I would pause this video at this point and I would add these two formulas, the product rule and the quotient rule, to your derivative formulas in the back of your notebook. I'm going to go through it right now and talk about them a little bit. So the product rule, basically you're trying to take the derivative of the product of two functions that are getting multiplied together. So one of them is here f of x and the other one is g of x. I'm going to call it the first function and the second function. So when you're trying to take the derivative of this product of two functions f of x and g of x, you take the derivative of the first one times the second one left alone, plus, now you take the derivative of the second one times the first one left alone. Derivative of the first one times the second one left alone, plus derivative of the second one times the first one left alone. And that is the product rule. Now for the quotient rule, we're trying to take the derivative of a function divided by another function, that is a quotient, a fraction. And I'm going to call the f of x the top. I'm going to call the g of x the bottom. So the quotient rule formula says take the derivative of the top times the bottom one left alone minus the derivative of the bottom times the top one left alone all over the bottom function squared. So it's the derivative of the top times the bottom left alone minus the derivative of the bottom times the top left alone all over the bottom one squared. So there's some similarities between these two rules. The first is, of course, that you're having the derivative of one times the other one left alone, derivative of the other one times the first left alone. With the product rule, since they're both on the top, you just pick one at a time, and then you add the answers. With the quotient rule, when you take the derivative of the top first and leave the bottom alone, that's a positive, but then you subtract the derivative of the bottom times the top left alone. And then, of course, the denominator is being squared when you're done. So those are the two rules. Now let's look at some examples. Okay, so we want to differentiate each of the following using the product rule, and then we're not going to simplify our answers. Right now, we're just practicing the product rule. So here you'll notice that there are two functions. X cubed minus 3x squared is one function. 2x to the fifth plus 7x squared minus 1 is another function. And I'm trying to take the derivative. So the derivative of f of x is going to be called f prime of x. And the product rule says take the derivative of the first function. So the derivative of the x cubed minus 3x squared. That's going to be 3x squared minus 6x, and then times the second function left alone. So leave the 2x to the fifth plus the 7x squared minus 1 alone. So I took the derivative of the first function, that's here, times the second one left alone, plus, now I take the derivative of the second function, so the derivative of 2x to the fifth plus 7x squared minus 1 is going to be 10x to the fourth plus 14x, and of course the derivative of negative 1 is 0. And now times the first function left alone, so x cubed minus 3x squared left alone. So again, this was the derivative of the second function times the first one left alone. So derivative of the first function times the second one left alone plus derivative of the second function times the first one left alone. And I did not want to simplify the answers. The point of doing this is to practice the product rule, not to actually get any answers right now. Okay, so here's problem number 2. Again, this is a product. This is going to be my first function. This is going to be my second function. I'm going to write this a little differently before I take its derivative. The square root x I'm going to call x to the 1/2. And then, of course, I have x to the 10th plus 2x to the 8th minus 5x cubed. And now I want to take the derivative using the product rule. So the product rule says that when I find the derivative, which is called dy dx, I take the derivative of the first function, the derivative of x to the 1/2. So it's 1/2 x to the negative 1/2. That's the derivative of the first function times the second one left alone. So times the x to the 10th plus 2x to the 8th minus 5x cubed left alone, plus, now I take the derivative of the second function, which is this one. So the derivative of x to the 10th is 10x to the 9th, plus derivative 2x to the 8th is 16x to the 7th, minus, and then derivative of 5x cubed is 15x squared, times the first one left alone. So I'm going to multiply by x to the 1/2. And again, we were practicing the product rule. We were not trying to simplify this. If I were actually to try to do this problem on my own, I would first write the x to 1/2 and I would distribute that in, and then it would be a lot easier of a derivative. But that's not what we're practicing today. Same thing here. I would distribute this all out and then I would take the derivative. I wouldn't be using the product rule in reality. However, the product rule is going to become necessary later on, so we're practicing at this point. So derivative of the first one times the second one left alone, plus derivative of the second one times the first one left alone. Okay, here's another one. Again, this is a product, first function, second function. So p prime of x is going to be derivative of the first function, which is 4x cubed minus 6x to the negative 4 times the second one left alone, x to the 5/2 plus 7x minus 2, plus, now I take the derivative of the second function, so it's 5/2 x to the 3/2 plus 7, and then the derivative of negative 2 is 0, times the first function left alone, x to the 4th plus 2x to the negative 3 left alone. So derivative of the first function times second one left alone, derivative of the second function times first one left alone. Now here I've got a product of 3 different functions, so we just expand this product rule into taking the derivative of one of them at a time and leaving the other 2 alone. It's not actually that more difficult, it's just more steps. So dy dx is going to equal, first I take the derivative of x squared plus 3, so that's 2x, and I leave the other 2 things alone, so 2x minus 5, x to the 4th plus 3x cubed. Plus, now I take the derivative of the second function, which is this one, which is just going to be 2, and I leave the other 2 alone. So x squared plus 3 left alone, x to the 4th plus 3x cubed left alone. Plus, now I take the derivative of the third function, so the derivative of x to the 4th plus 3x cubed is 4x cubed plus 9x squared, and I leave the other 2 alone, so leave the x squared plus 3 alone, and leave the 2x minus 5 alone. So again, this expands out. You just take the derivative of one of these at a time, leaving the other 2 alone. So you take the derivative of this one first, leave these 2 alone. Then you take the derivative of this one, leave these 2 alone. Then you take the derivative of this one, leave these 2 alone, and of course add every time. So that is the product rule. Now we're going to practice doing the quotient rule. So again, differentiate each of these using the quotient rule. Do not simplify your answers. So again, I want to use the quotient rule. Before I do the quotient rule, I don't like that square root x. I'm going to write it this way: x cubed minus 7x over 2x plus x to the 1/2. Okay, so what the quotient rule tells me to do is to take the derivative of the top times the bottom left alone, minus take the derivative of the bottom times the top left alone, and then divide by the bottom one all squared. So f prime of x equals derivative of the top, well, that's going to be 3x squared minus 7, times the bottom one left alone, so 2x plus x to the 1/2, minus, now I take the derivative of the bottom, 2 plus 1/2 x to the negative 1/2, times the top left alone, x cubed minus 7x left alone, divided by the entire bottom, 2x plus x to the 1/2, quantity squared. So again, what I did was derivative of the top times the bottom left alone, derivative of the bottom times the top left alone, and then divided by the bottom one squared. Derivative of the top times the bottom left alone, derivative of the bottom times the top left alone, of course subtract them, and then bottom squared. So here's one more. P of x equals 2x minus 1 over x plus 3. I want to find p prime of x. So the derivative of the top, so the derivative of 2x minus 1 is just going to be 2, times the bottom left alone, x plus 3, minus derivative of the bottom, the derivative of x plus 3 is going to be 1, times the top left alone, 2x minus 1 left alone, all over the bottom, x plus 3 squared. So that's the quotient rule again. Derivative of top times bottom left alone, minus derivative of bottom times top left alone, all over bottom squared. Here's another one. Again, I don't like the way this is written, so I'm going to write it a little differently before I take the derivative. So this is x to the 1/2 plus x to the -1 plus e over x to the 5th minus 3x cubed plus x. So now again, when I do the quotient rule, dy dx equals, first I take the derivative of the top. Well, the derivative of x to the 1/2 is 1/2 x to the -1/2. The derivative of x to the -1 is minus 1x to the -2. And the derivative of e, well, e is a constant. E is 2.7, etc., etc., etc. So the derivative is 0 times, now the bottom left alone. So x to the 5th minus 3x cubed plus x left alone. Minus, now I take the derivative of the bottom, which is 5x to the 4th minus 9x squared plus 1. And then I leave the top alone. So times x to the 1/2 plus x to the -1 plus e left alone. And then divide all of this by the bottom squared. So again, derivative of the top times the bottom left alone minus derivative of the bottom times the top left alone all over the bottom one squared. One more example. If f of x equals x squared plus 2x plus 3 over x minus 1, find the equation of the tangent line to f of x at x equals 0. So first of all, I want the equation of a tangent line. The equation of any line is going to be, for example, y equals mx plus b. Now, I don't have to actually have this version, but this is one of those versions. I could do it as a translation instead of as a slope-intercept. But I think this is actually going to be the most convenient way to do it. So anytime you want the equation of a tangent line, this is kind of what you're thinking in your head. Now, a couple things to think about. Tangent line, well, that means it touches at exactly one point. What point is that? Well, in this case, the tangent line to f of x at x equals 0. So to get a point for that tangent line, I need to plug x equals 0 into the function. So for the point of my tangent, C, I have f of 0 equals, well, if I plug in 0, I get 0 squared plus 2 times 0 plus 3 over 0 minus 1, so it's -3. So the point is 0, -3, and wait a minute, that's actually the y-intercept. And this is why I was saying that y equals mx plus b is actually going to be convenient, because I already have the y-intercept because I have x equals 0. Now, the next thing I need for my tangent line is to know its slope. So to get the slope of the tangent line, I need a derivative. So let's first do that. So f prime of x is going to equal, well, this is a quotient rule problem. So first I take the derivative of the top. So it's 2x plus 2 times the bottom left alone times x minus 1 minus, now I take the derivative of the bottom, the derivative of x minus 1 is just 1, times the top left alone, x squared plus 2x plus 3 left alone, all over, and then the bottom squared. Now, what this is the derivative function. This tells me the slope of the tangent line anywhere on the function. I don't care about anywhere on the function. I care about the place where x equals 0. So I'm going to take my x equals 0 and plug it into this. So I'm going to get the slope is going to equal f prime of 0, which is going to be, and I'm not going to bother simplifying, I'm just going to plug in 0 because it's going to be quite convenient. Well, that's going to be 0 plus 2, 0 minus 1, minus 1 times 0 plus 3, all over 0 minus 1 quantity squared. So because of the fact that I was using 0, these calculations are relatively straightforward. So let's keep it going. So this becomes 2 times negative 1. That's negative 2 minus, and then 1 times 3, which is 3, all over. And then here I've got negative 1 squared, which is positive 1. So this is negative 5. So the equation of the tangent line at x equals 0 is y equals negative 5x minus 3, because negative 5 was the slope, negative 3 was the y-intercept. So there is the equation of the tangent line. And how did I do it? Well, I needed a point, I needed a slope. To get the point, I plugged the x equals 0 into the function to get the y-coordinate, and that happens to be the y-intercept, which is convenient. To get the slope of the tangent line, I took the derivative function, so I just took the derivative using the quotient rule, and then I plugged in the point value, the x value anyway, to find the slope at that x value, and I got negative 5, and so the equation of the tangent line ended up being y equals negative 5x minus 3. And that is the end of today's lesson.